universe burst into existence. Soon followed galaxies, stars and planets. This was the evolution of our cosmos. And our understanding of it has taken a massive leap forward in recent years.
Our picture of the universe has changed in the last couple of decades more than it had in the past 100 years.
I really think this is a golden age of astronomy.
We live in a really preposterous universe.
Almost everything we thought we knew about the universe is wrong.
Before Catalyst was on air, black holes were thought to be largely incidental to the cosmos. Now they may be a key to it, because of the surprise discovery that the very earliest galaxies had giant black holes at their centres. Surprising, because big black holes were thought to form by lots of little holes falling together.
And so gradually at the centre of a galaxy you have these things falling together, clumping together to make these really big black holes. But the trouble is that process takes billions of years. And so we're seeing these things 500 million years after the Big Bang, and they cannot form by that process.
How could they form so early in the universe? Well, that's a complete mystery.
Right now we've just got this hint there's something really exciting going on. Black holes are much more important than we thought they were 10 years ago. They really seem to be fundamental to the way that galaxies work.
Our knowledge of the Big Bang itself has also galloped forward over the last decade.
What's really changed things is the most precision measurement in cosmology, which is looking at the cosmic microwave background radiation, the afterglow of the Big Bang.
Back in 2003, a satellite with a name only an astronomer could love, WMAP, studied the afterglow in unprecedented detail and produced this famous image. They're the ripples in the Big Bang itself. And the pattern in them encodes some remarkable information.
Looking at that and measuring the abundance of elements in the universe has told us how many protons and neutrons are in the universe.
Those protons and neutrons became all of the normal matter in the cosmos.
Because it's like making a soup. You drop in some protons, you drop in some neutrons, you end up with elements.
WMAP also confirmed cosmic inflation, the radical idea that a mysterious energy suddenly inflated the universe very early on.
Tiny, tiny fraction of a second after the Big Bang, this energy just suddenly blows out the whole universe by many, many orders of magnitude in a very short space of time. So it goes very, very rapidly like this.
Just as our understanding of the Big Bang was becoming more precise, astrophysicists suddenly got a shocking surprise. It came while measuring how fast the universe was expanding in the past and comparing it to the present.
So when we see a nearby object, we measure how fast the universe is expanding now. When we see a distant object, we see how fast the universe is expanding then. And when we did that measurement, we expected the universe to be slowing down over time.
Any sensible universe should slow down. Why? Because gravity sucks, okay? It always pulls, it never pushes. And so gravity should be slowing down the expansion of the universe, the attractive force of all the stuff in the universe.
What we found instead was that the universe was speeding up over time. And that seemed crazy. That's sort of like me throwing a ball up in the air and having it just take off into orbit and disappear. You would say, obviously I'm missing something.
Wow, where did that come from? You know, that's totally unpredicted. It came as a complete blow to everybody.
It turned out everything in the universe was being pushed apart by the energy of empty space, dubbed dark energy.
We've discovered that 70% of the energy of the universe resides in empty space. It's totally inexplicable. It's changed everything.
We don't know what dark energy is. What it is a label. Imagine the whole universe is filled with this thing, something. We don't actually know what it is. We don't know how it works. But it's a property of space. And it's filling the entire universe. And that's about all you can say about it.
It's a puzzle astronomers hope to solve in the next decade. The discovery of dark energy wasn't the only surprise for astrophysicists over the last decade. Our understanding of another dark mystery has now completely changed. This one is dark matter. Matter that's in every galaxy, but invisible to telescopes. However, it influences how a galaxy spins.
For example, the Milky Way, or any spiral galaxy, it's rotating. We can see the velocity with which it's going around and around. And then we say, oh, in order for this to be going around that fast, there has to be so much mass in the center. We count the stars in the center. We count the gas in the center. It says, no way is that going to hold in that velocity. There has to be dark matter.
As we reported several years ago, non-dark matter, stars and gas, are only a tiny fraction of what's in a galaxy. But all of that matter put together is just 10% of the total universe. There's still 90% out there that they know virtually nothing about. Before Catalyst, astronomers thought the dark matter was made up of things like dark stars and many black holes, together known as machos, massive, compact halo objects. Now they think it's composed of tiny and so far undetected particles created in the Big Bang, weakly interacting massive particles, WIMPs.
Determining the origin and nature of that dark matter is probably still one of the biggest puzzles in physics and cosmology.
The hope is the puzzle might be solved at CERN in the Large Hadron Collider. Catalyst visited the atom smasher a few years ago. Now, this really is mind-boggling stuff. Inside here, there are protons whizzing around the circuit, and they travel in bunches. There's about 100 billion protons per bunch, and there are a few thousand bunches spread around the whole 27 kilometres. Now, they're travelling at 99.99999999, that's 8 nines%, of the speed of light, and then they're brought into a head-on collision. It's like a mini Big Bang, and just like in the real Big Bang, a whole host of particles are created. Of all the different types of particles created in the Big Bang, physicists have so far found and categorised 36, the ordinary matter particles. But theory predicts another 36 were also created. They're called supersymmetric particles, and they're the mirror images of the ordinary ones. Some of them could make up dark matter and should be created in the collider. The next decade will be fascinating to see how all these new ideas about dark matter, dark energy and the Big Bang pan out.
Who knows, that those ideas might be wrong. In fact, what people don't understand about science is most ideas are wrong. That's what makes it exciting. We like to be wrong, in fact, because it means there's something else to learn about the universe.